What's up, YouTube? This is the fifth video on Kyle's Global Weather. Today we're going to be talking about microclimates, and we're going to be specifically talking about San Francisco. This is going to be an extension of all the previous videos, and we're going to incorporate a lot of the other concepts that we've been talking about. We're going to be planning on making some short-form content soon. With the friends, we're using Premiere Pro and After Effects and some other applications. We're going to be making some nice, high-quality content, and hopefully we're going to boost the algorithm so that people can really see this good content that we're producing on this channel. I'm currently using Loom as I have been for all these past videos, and I actually had to switch my account because the free trial has been preventing me from downloading the videos after they've been produced. Unfortunately, this is the case. I might have to switch to a different platform. It might be a lot better. I think Loom is very restricting with its free trial. So without further ado, let's just get right into the video. Just to reiterate, this is going to be about microclimates in San Francisco. So what is a microclimate? In simple English, it's just the climate of an area being a little bit different than like the climate of the area around it. And this could be in so many different forms, but today we're just going to be talking about the one in San Francisco, which is just an example of a coastal climate being different from the surrounding areas. And as we talked about from our previous video about humidity really has to deal with temperature, and it has to do with temperature in the ocean. That's one of the main factors that contributes to changes in humidity. In San Francisco, changes in humidity play a huge role in how fog forms, and fog is the hallmark of the San Francisco microclimate, and that's what we're going to be focusing on all about today. So how does fog form? Well, I didn't really make it too clear in the past video, but basically water eventually comes to a saturation point. In our past video, we talked about warm, moist air rising up. With fog, it's a little bit different because that air doesn't actually rise up. It just comes in contact with the cooler ocean water. When that warm air cools down, which is going to cool down at this lower elevation here, the air is going to reach a saturation point, which means the water vapor is going to be more likely to convert into liquid form. Fog is essentially the same thing as a cloud. It's just lower to the ground. And it happens in many different areas during many different times of year. But in San Francisco, this happens like pretty much all year long in different forms and different intensities. You got the warm air with the winds going over the cold water, and they interact. And fog forms, and it's dense in color, just like clouds are. So how does it change as the day goes by? This is just going to be a general rule, but we're going to talk about San Francisco more specifically. So we're going to start off with strong winds. This is going to be one of the most complex things we're going to be talking about. There's many different things that strong winds can do in terms of fog. If you have winds that are too strong, it's actually going to blow away the air particles. It's going to expand them into more space, right? And then therefore that fog, the moisture particles in the air are going to become more spread out. It's going to become more patchy. If the winds are strong enough, this only creates a cyclical effect. With the air being more spread apart, it's just easier for it to spread apart even more because that broader air is going to be interacting with more air. So that's how fog can entirely dissipate at times. It's also going to encourage vertical mixing. It's when different levels of the atmosphere interact with each other. And that is actually going to inhibit fog, and it's going to dissipate fog because fog forms when conditions are still, and it is maintained when conditions are still. And it's really, there's a complex thing going on where you have the warm air from the ocean, and then you have the cooler air coming off from when, evaporation occurs, and those water particles take heat and then cool the surrounding air. Right, the strong winds, a lot of the time, they'll blow this warm air into the region, and that is going to overwhelm that cooler air that forms as a result of evaporation. When that happens, the likelihood that the warmer air is going to produce fog, it's going to reach its saturation point, it's just going to be lower, right? It's just going to be warmer air that's going to dominate. So fog is just not going to be produced in the future. So a lot of the time, stronger winds inhibits fog. But sometimes, lighter winds can actually encourage it in very specific scenarios. Another thing is upwelling, and it's another after effect of strong winds. That's the main thing of upwelling. And upwelling is just a general term to describe lower portions of the ocean moving up. Stronger winds pushes the topmost portions of the water away. And over time, lower portions of the ocean are actually going to rise up. And it's cooler down there. And what happens when there's cooler waters is the air is going to become cooler. And then that's again going to encourage um, fog to form because the air is going to reach a saturation point easier. If you'd like to just think about this in terms of science, cooler air has slower moving particles, right? Lower energy. And when that happens, it's oftentimes that the water vapor is just going to slow down and it's going to have nowhere to go, right? It's going to have to condense. And that's why fog is formed. And then a lot of it is also dependent on the time of day. During the nighttime, is going to be more dense fog. Then during the daytime, it's not going to be as intense because the heat of the daytime is going to end up, reaching those set effects as it's going to increase the temperature of the air, which is going to decrease the likelihood of fog forming. Regardless, in both scenarios, heat is often trapped under fog because it simply cannot escape as easily. When this happens, there's just simply less temperature fluctuation. We'll get into some more effects that fog has on the weather later on, but just like to say that as a preface. So this is fog in general, right? But what makes San Francisco unique? Let's talk about the broader area. There's these gyres that exist, and there's about 5 of them in the world, but we're just going to be focusing on the North Pacific gyre. Gyres are formed pretty much due to the Earth's rotation and the Coriolis effect, which I have not detailed at all, but they're just broader streams of water moving around, as you can see in this image over here. Warmer air, not just water is moving from northwestern areas of America down to the southwestern areas. And this is just a zoomed in version right here. The California current just indicates those water areas moving down. And then what else makes San Fran unique? You have the mountains. You have the Santa Cruz Mountains, mainly to the south, and then you have other mountain ranges that enclose it from the north. And then you just have lots of water. All of these things are going to play a huge role in why the weather is so unique there. Let's talk about it right now. California current. That is cooler water just riding down the coast of the western United States. This is just going to encourage fog in coastal areas, right? You're going to have the warmer air. It's going to be cooled down interacting with this cool water, and then fog is going to form. You have these mountains. Oftentimes, the jet stream is going to be positioned right around these areas, and the mountains are actually going to block some of this prevailing winds. We call it prevailing because it often flows in one direction. Obviously, in this case, it's going to be from left to right, from west to east. When that happens, the winds are going to circle around, and this can often promote fog or dissipate fog, but that's just a variable we're going to be looking at that people look at a lot of the time when explaining why this happens so much in San Francisco. And then there's also lakes and bays. There's just so much water that could possibly be interacted with and manipulated with, and that can cause fog to form in just so many different areas. It's often in the most coastal regions that we're going to find fog, but just because there's so much water, just so many areas, fog can often reach overlands and just enclose so many different areas. But there's one type of fog I like to get more detailed in. It's called tool fog, and it's a specific type of radiation fog. Just has to do with the amount of heat that comes in as a result of the fluctuation of the day. This happens in the winter. The ground is extremely cold, and it just promotes heavy amounts of fog to occur. You have warmer air coming in, just crashes down, and it's going to form fog. And the saturation point just goes down and down and down. And this is only amplified when there's already precipitation in the air because that's when fog can stick to those particles, and it's going to stick around for a long time. In cooler air, it's often going to be moving slower, right? Fog is disrupted a lot of the time when air moves around faster, and this is how it gets its distinct name. And it pops up only really in regions of like California and Nevada. It's like it's really specific to certain areas. You can just see how it pops up in this image. It's obviously enclosing a broader area of California, but I can assure you, San Francisco sees the highlight of it. And this is just what it looks like. It's just so like you can't see anything through it. It's like negative visibility. I don't know how you live in this. This is something that happens in the winter months of the time, San Francisco. Why do we care if there's fog? Well, as you can see by those images, one of the effects is low visibility. It's going to make all different aspects of life hard, right? Sports, travel, work, transportation, anything. There's also going to be less temperature changes. I mentioned before, fog inhibits air masses from moving apart and along different areas, and that's going to lead to just temperature conditions not fluctuating that much. Also, fog can create its own little microclimate in which moisture is going to stick to surfaces and then fall as almost a little bit of rain. Now, this isn't really considered rain, but it's kind of an after effect of fog really enclosing the whole atmosphere. And then fog is also just has over millions of years influenced the wildlife and animals that live there. They've all become accustomed to this kind of weather. It's really profound. If you were to move like tens of miles, north, south, or east, you would see totally different climates. Right? It just becomes total sunshine. But then as soon as you move down into San Francisco, you just have all these effects happening here. If we want to get more technical, all sorts of after effects and just like correlations to when like fog is situated in certain areas. Something called a marine layer, and it's basically used to describe the air mass that forms when there's when there's air inversion, as we described before, when you have cooler air below warmer air, right? That's called inversion, and that's just basically a way to describe it. And it happens a lot of the time. So that's one of the microclimates. There's like countless of them in the world. There's no real classifications for them. You can call them coastal climates, microclimates. You can call them like the desert microclimates, anything. But we're actually going to talk about why New York could be considered a microclimate in a second. And here's some future videos. Let me know in the comments if these seem interesting. We could be talking about so much more about that, potentially, just microclimates in general. I'd also like to expand on fog. There's actually 4 or 5 main different types of fog we just haven't like covered in this video. I just described like the general process in which fog is formed, but we can go more into depth later. And then we can go into depth about the marine layer, which is what I just talked about. So let's talk about New York City. I would call this I would call this a pollution microclimate. We don't have to get really in depth at all, but in New York City, so much pollution that it ends up warming the air, and it's considered a microclimate because if you were to go like 20 miles in a different direction, there's not going to be as much pollution, and temperature changes like dramatically, right? It's going to be a few degrees cooler. Like it's so substantial. Sometimes in other areas, it could be south of the city and it'll receive snow, but not New York City itself, just because there's so much pollution and it's a microclimate there, which is kind of unfortunate for that specific case. Um, Also, I don't have this pulled up right now, but if you were to go back and look at San Francisco over there, you would just see how uniform the weather is. If you go back to like the time of day, honestly, even year round, temperatures are just going to be so uniform. Whereas like the rest of the state is just going to be so different. Okay, now let's get into New York City's forecast. This is the geopotential height anomaly map. We've discussed this in like our second and third videos, but we're going to look into the future. As we can see, we got above average heights with ridging in the southeast. This is just going to indicate, air and moist air specifically moving northwards. As time progresses, we can see this only amplifies, and it brings its way towards the more eastern sections like the tri-state area. It's going to create a storm system when you have these cooler, right, over here, and then warmer air masses interacting. And you can see these heights actually get very low. You're going to see a lot of cooler air coming here. I'll show you on the temperature map just in a second. It hangs around for a few days, but then all of a sudden the heights begin increasing in this area, and you've just got back to normal temperatures. And it's just a little bit too far to predict with reasonable accuracy. If we go to the precipitation map, oh, I lied, I'm not showing you a temperature map, but yeah, this is really just explaining what I just said. You have just moist air moving all across the tri-state area, the eastern U.S. It's going to be repeated showers for the next few days. I think this will be most intense around Wednesday, like this is showing here. See these like yellow dots? That really indicates strong systems. That's what you got to be careful of. Whereas Tuesday, it's really just a front with like a widespread area of light to moderate rain. This is just going to be a lot heavier. Same thing with the snow, man. There's some areas that could get a few flakes. It's April, like should not be happening. But yeah, anyways, it's gonna be cooler for a few days. I'm gonna show you here in a second. This is the future forecast. Tuesday, Wednesday, Thursday, the Weather Channel predicts it's gonna be raining. Oh yeah, also, I predicted that last Saturday was gonna be like a few degrees warmer in Celsius. It was. It was 16 degrees Celsius, and it was predicted that it was gonna be 14. So trust my word over the Weather Channel. As for future predictions, I don't know. I don't got too much to say. I think like if you look at the forecast, I think it's going to be more. This is 25 millimeters. I think it's going to be more than a foot. Yeah, I think it's going to be more than a foot. I think it's going to cause some damage. I might put that in a community post somewhere, but I think an inch of rain is a little bit conservative. And then for the future forecast, I think it could be a little bit warmer. Saying like Monday is when it's going to start warming up a lot. Could happen a little bit sooner. I don't know how accurate this is. Just based off just what I think, it could be. It's going to take like 3 or 4 days for there to fully warm up. Yeah, it just doesn't make sense to me, but it might happen. All right, guys, this is definitely a lot longer than I anticipated. I wanted this to be like 10 to 12 minutes. That's what we're going to keep future videos to be. Um, yeah, I just hope you guys learned a lot. I honestly went through like 2 videos in one here. Could have split it up, but just happy I was able to get some good information out. All right, see you guys in the next one, and stay tuned for some good short form content coming up. All right, peace.